Hi everyone, it's Bailey Brown again, and today we'll be going over Module 1, Chapter 1, the 6 questions from this section. So I'm going to screen share and take you to my PowerPoint. So Module 1, Chapter 1, Thinking Critically. So this is question 1, Part A. So we were given the numbers 11, 13, 12, 10, and 8. And they were not set up like this in this order. They were just the numbers given. But what they did say was that it had to be set up in this kind of cross pattern. So, and I understand what they were doing because we need the numbers to add up vertically and horizontally. And so when you add them this way and you add them this way, then you get the same numbers. And so a question that some of you may have would be, can we use any numbers to do this? And the correct answer would be no, because the numbers have to add up to equal the same thing horizontally and vertically. So another question that you may be having is there an easier way to do this than trial and error? And the answer is no. That's the only way that I found, and it is the easiest way that I have found to do it, is just trial and error. Move the numbers around and see what you can get. How could this be useful? This could be useful if you owned a restaurant and you had 2 rooms that required the same number of chairs in each, but had to be set up differently. So this may be able to help you figure out how you would do that. So we're going to move on to part B of this question, where we've got 4 different problems. So what you're supposed to be able to do with this is in each corner is going to go you're going to go 13 minus 11. So right here should be a 2. Now I'm going to go ahead and say that none of these 4 problems work. And I'll tell you why. Because 12 plus 7 does not equal 15. So this entire thing is scrapped. It doesn't work. 13 plus 6 does not equal 21. So it doesn't work. 6 plus 3 does not equal 8. So it doesn't work. And 9 plus 8 does not equal 18. So none of these problems work. But what should have happened was right here where it's got a 6 and an 8. So we should have had a 2 right here instead of a 3. And then we could have continued and done 15 minus 8, and the answer would be there. The 15 minus 12 and the 3 would go there. 12 minus 6 and the 6 would go there. And then you would have a complete thing. But since there is a wrong answer in every single one of these, none of these work. So, and some of you may be asking, well, how in the world what is the difference between A and B? Well, in A, we are adding vertically and horizontally to get the same number for each. And for B, we're subtracting these 2 numbers beside the blue boxes or the blue circles to give us that answer right there in the middle. So that's what the difference is between part A and part B. So we're going to move on to question number 2. And the question was, if you have 9 square tiles laid out and they on a table and they all had to be touching at least one other tile, what would make the smallest perimeter and what would be the largest perimeter? So the first thing I'm going to say is that for us to find the smallest perimeter, you're just going to have to lay it out at a 1 by 9, and you're going to count each side. Well, there's 1, 2, 3, so there's 9 here. There's going to be 9 up here. So that's 18, 19, 20. So that is 20 units around. And that would be the longest. That's the biggest perimeter. So for the smallest perimeter, we're going to set it up by a 3 by 3. And that's going to make it more compact. So we've got 3, 6, 9, 12. So that is the perimeter, 12 units of this one. So some of you may be asking, how would this be useful? This would be useful if you were, say, organizing your cans in your pantry and you wanted to maximize your space and be able to find your things easier. This is how you would do that. Could you arrange this any other way? You could arrange this in many, many ways, but not to get the smallest or the largest. This would be the largest, and this would be the smallest, with one side of each tile touching. But you could set this up many ways as long as you have one side of the tile touching. So this is question number 3. There is a lot going on in question number 3. I'm going to say that. So what we have right here, I'm going to point out that this little thing, this is a comma. This is not a dot, because that threw me off. But we have, right here, we have a diagram basically showing what we have going on here. So we've got one dot, so it equals 1. Right here, we've got 1 plus 4 more dots, so that equals 5. So we just added 3 there. 1 plus 3 equals 4, so 1 plus 4 equals 5. See what we're doing? We're adding 3 to each number. All right, so we've got the 1, 5, 12, 22. So what we did here, from the 22, we have 1 plus 4 plus 7 plus 10 equals 22 dots total. So what we're going to do, 10 plus 3 equals 13. So we're going to do 1 plus 4 plus 7 plus 10 plus 13, and we're going to get 35 dots. I could not make the perfect pentagon. I tried, but there's 35 dots here, and so that would be what would come next in the pattern. So after that, we've got, we're going to add 3 to this 13 to give us 16. So 1 plus 4 plus 7 plus 10 plus 13 plus 16 equals 51. Again, tried to make a good pentagon. Didn't really work out that way, but there are 51 dots right here. So how would this be helpful in life? I want to say I don't think it would be helpful unless you worked at a bowling alley and the pin setter broke. That's my thoughts on that. Can you set this up in a different shape? Sure. As long as you were following this numeric pattern, you can set it up in whatever kind of shape makes you happy. So what is the pattern? The pattern is simply just adding 3 to the last number in the equation. And what would the next number of dots in the equation be after this 51? So we would add 3 to the 16 to give us a 19. So we do 1 plus 4 plus 7 plus 10 plus 13 plus 16 plus 19. So that would give us 70 dots. I did not draw a picture because that is a lot of dots, and y'all get the point. But it would be 70 dots in the shape of a pentagon. All right, so moving on to question 4. So what we were given here, it's kind of hard to tell, but these bold numbers are the ones that I put in. All right, so we were given on the bottom row an X, 7, and a 3, and on the very top a 25. So this is very simple right here, what we've got going on. We are just adding these two numbers. We got 7 plus 3 gives us 10. So y'all are wondering what is going on. So first question that I'm assuming you're asking is, what are we going to do for A? I'm going to explain all of that thoroughly. So your first step is you're going to start right here, and 7 plus 3 equals 10, right? So that's your first step. You're done with your first step. Second step is 25 minus 10. So that's going to give you this number right here, which is 15. And 15 minus 7 is going to give you this X that's right here in this corner. So A is done. Next question, what are we doing in B? Okay, so we were given 1, Y, 2, and 15. Set up the same way except for the variable is moved to the center at the bottom. All right, so this one's going to be more of a trial and error. It might take you a little bit longer. So what we're doing is we are finding numbers that are going to work for this whole thing. Basically, you're going to have to figure out what Y is. So I came up with 7 plus 8 equals 15. And so 7 minus 1 is 6, and 8 minus 2 is 6. So Y equals 6. That's right here in the center. All right, your next question, what are we doing in 3? All right, they gave us this 27, Z, 2, and 9. So we're finding these two spots right here. All right, So again, it's more of a trial and error sort of thing. So really the biggest number that we need is this middle one at the bottom. That is the most important. All right, so I did a lot of trial and error, and I got 8 plus 9 equals 17. So then you're going to do 27 minus 17, which is going to give you the 10 that's right here. And to double check yourself, you do the 2 plus 8, and this z, which is 10, it checks out. So it's all good. All right, and so some more questions that you might have would be, could there be more than one answer to each of these? And the answer is no, because you're needing the numbers below to add up to equal this, and these two numbers to equal this number on top. So there's no way you could have more than one answer. And another question might be, could you do this with another shape? Couldn't do it with another shape necessarily, but you could do it in a bigger scale. But it has to be set up in a pyramid type shape, otherwise it doesn't work. All right, and now we are to question 5, and it says 4 married couples belong to a bridge club. The wives' names are Kitty, Sarah, Josie, and Ann. Their husband's name in some random order are David, Will, Gus, and Floyd. Use the table below to sort out who is married to who. All right, so we have Floyd is Josie's brother. So that's gonna take out Floyd from Josie. He is gone. So he is available for these next 3. Okay, Josie and Gus dated some, but then Gus met his present wife. All right, so Josie and Gus dated, but they're not anymore. So they're not, he's married to someone else. So that's going to take Gus out from Josie. So she can't be married to Gus and she can't be married to Floyd. All right, Kitty is married to Will. Very simple. So that takes out David, Gus, and Floyd from hers. Okay, Ann has 2 brothers. This is in here simply to distract you. You do not need this. Okay, Ann's husband is an only child. Again, I assume it is only in here to distract you. I'm not going to mention your questions on this because I myself am a little confused on this question, so I apologize. So now we are on to question 6, and it says, consider the trapezoidal numbers, 1 plus 1 plus 1, then 1 plus 2 plus 2 plus 2 plus 1, 1 plus 2 plus 3 plus 3 plus 3 plus 2 plus 1. The nth trapezoidal number is 1 plus 2 plus ... plus n plus n plus n plus ... plus 2 plus 1, where n is a positive integer. All right, so what the first question was with this scenario was to turn this 1 by 1 by 1 into a dot formed pattern. So I've done that. It is a 1 by 1. There should not be 3 dots. It should only be 1 dot. No, that's right. I'm sorry. That's right. Okay, anyways. So this next one, this 1 plus 2 plus 2 plus 2 plus 1. That makes a 2 by 4. And then this next one, the 1 plus 2 plus 3 plus 3 plus 3 plus 2 plus 1, it ends up being a 3 by 5. All right. So that was the question of what are we doing? We are turning these trapezoidal numbers into a dot formed pattern. All right. Another question you might have is if we wanted the row to be twice as long as the column, what would we do? I have a pretty simple answer for that. We would turn this right here sideways, so that way it would be 4 by 2. Yeah, and then what is the pattern? Well, the pattern is the 1 plus 2 plus, you keep going, whatever numbers, plus n plus n plus n plus whatever numbers, plus 2 plus 1. All right, and then what's faster, putting all these dots out or following this equation right here? And definitely this equation is faster because you're not sitting here counting dots. You were just following the numbers. It makes it so much simpler. All right, and then what would the next sequence be? It would say 1 it would say 1 plus 2 plus 3 plus 4 plus 4 plus 4 plus 3 plus 2 plus 1, which makes it end up being a 4 by 6. All right, that's all I have for y'all today. I want to say thank y'all for watching and hope y'all have a wonderful day.